In this first stage, the wastewater is left to settle. Heavier solids sink while oil floats to the top. This helps stabilize the flow before treatment begins. This stage focuses on pH correction. We add lime juice to mimic alkaline dosing, causing the red cabbage indicator to turn pink, showing an acidic pH around 4. Baking powder is then added gradually. As the solution turns brown, it indicates a near neutral pH of approximately 7. This step is essential to ensure microbes can survive and function effectively in the next treatment stage. Here, we simulate aeration by introducing yeast and sugar. The yeast brings microbes, and sugar acts as a nutrient source. Rainwater is added to create bubbling, which mimics the oxygenation process found in real aeration tanks. This bubbling increases dissolved oxygen, encouraging aerobic microbial activity to break down organic pollutants. The final stage uses a gravity-based filtration system built from recycled materials. The filtration layers include sponge for large debris, coffee filter for intermediate solids, charcoal for odor and chemical absorption, and fine sand for final polishing. As water passes through each layer, solids and contaminants are progressively removed, resulting in visibly clearer effluent.
Stage, water travels through a dense, layered bed of activated carbon granules and microsand.
Before the treatment process, the wastewater was cloudy and thick with a visible oil layer floating on the surface. It emitted a strong, unpleasant odor and had an acidic pH level, making it unsuitable for safe discharge. Organic residues from yeast, sugar, and baking powder were also present, contributing to a poor water quality and instability. After 1 hour of treatment, clear changes were observed. The oil was completely removed, the water turned clear brownish, and it became odorless and non-cloudy. The pH level naturally improved from acidic to neutral. Although the volume reduced from 800 ml to 700 ml, it was due to absorption by the recycled material used in the process. This project successfully stimulated a real wastewater treatment system using only recycled and natural materials. It proves that even a small-scale model can make a big difference in improving palm oil mill effluent in a sustainable and eco-friendly way.
Inside what we learned. The first one, we now understand how each treatment stage from equalization to filtration. Next, red cabbage taught us how to test and adjust pH naturally. Next, yeast and sugar help us simulate how microbes clean wastewater. Filtration needs the right layer in order to work properly. And lastly, we learn to be creative, solve problems, and work as a team.
So for the first, we planned an automatic flow system, but the cost and setup were too difficult. The filter layers kept collapsing until we found a better way to arrange them. The aeration tank overflowed when yeast reacted too much. Time, materials, and trial and error pushed us to adapt and improve.